Hello everybody, welcome to the next class on the optimization technique. Today we will discuss about the MATLAB code of the Vogal Approximation method. It is also abbreviated as a VAM method. So myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You can feel free to contact me by either of my email ID or through my websites out there. So before starting this Vogel approximation method, we just quickly recall that what is the VAM and how we can solve this manually. So look at this transportation problem. There is some supply and demand, and then 3, 3, 4, 1 are the cost which transform from the source A to the destination D1 and so on. So you have to find the initial basic feasible solution with the help of the VAM method. So whenever you are trying to solve this in the VAM method, either in the MATLAB programming or through manually, so the first step is you have to check that whether it's a balanced or the unbalanced. How to check that it's a balanced or unbalanced? You add this and then there is a total supply and total demand. And if you add them, you can see that this is the balanced problem because both have 300. If it is unbalanced problem, then you have to add the dummy row and the dummy column depending upon that whether the supply is greater than demand or less than. Now since it's a balanced transportation problem, so what we do in this VAM method, we have to firstly find the penalty in the row wise and penalty in the column wise. So how you find the penalty in the row wise is find the two smallest number in the first row, that is 1 and 3. Take the absolute difference between them, 3 minus 1, 2. Similarly here 2 and 2, that's a 0, 1 and 2 is 1. Similarly you can find for the column, look at that, 1, 3 is here and so on. So this is the first step. After that you have to find the allocation. How you find the allocation in the VAM method? Look at the penalty row and the penalty column. Find which one is the highest value. So in this case there are the two values which are same. So it means you have to enter through this or through this. Then the rule for finding the elements corresponding to this is you have to prefer the cost to be the minimum. So what is the meaning is, look at in this column which one is the minimum element, 1. In this column, in this row, which one is the minimum element is 1. Now since there is a tie between the smallest element, so if there is a tie between the cost minimum, then you have to find the allocation as a maximum. For example, if it is a 1, then say it is say by 4, then since this is a minimum, so you have to assign the allocation corresponding to this 75 and 120 as a minimum. But right now it's a tie between them, so you have to find the allocation as the maximum. So what will happen if you allocate the elements at here, that is 25 and 100, and what is the minimum of 25 and 100 at this position? At this position this is 25, while on this position it's a 75. Now here the costs are equal, but allocation you prefer the maximum, so this one is the first allocation. So this is called as the occupied cell. So our first task is always to find the occupied cell, that is the 3, 1. So similarly, once you are finding here, then you again find the penalty and row and penalty column. But since this 75, now here is the remaining element. So since there is no more supply, so you have to delete this row. Now again find the smallest two elements in the first row, that is a 1 and 3, penalty 2, 2 and 2, 0. Since there is no supply, so there is no 1. Now in here is 3 and 4, so it's a 1, 3 and 2 is a 1 and so on. So you will get this one. Now again you have to repeat the process again and again. Now look at which one is the maximum in this green color and the red color. Now this is the maximum. This is the only maximum. So you have entered through this and choose the smallest one, the smallest element this. Now there is no tie between them, so you have to allocate the value at here. This is 25, the remaining is 75. Now there is no demand here. Now you can cross this and again find the allocations and so on. So finally you will get this optimal feasible solution corresponding to this transportation problem. Now we will apply the same rule into the MATLAB program. That is, remember this, we have to find the cost minimum and allocation as the maximum. So let's start with this same problem on the MATLAB file. So how you start on the MATLAB file is you just write one by one whatever I have written here on your MATLAB file. You will get the complete code, and it's a generalized code. You can use any of the transportation problem. So you can write firstly format short clear all and CLC. Look at that. You just type here on the MATLAB window. Whatever I have shown you in the screen, you just type it into your MATLAB file. Now look at this problem. So first step is always with the input phase. So how many tasks are there? You have the cost element. So how you write this? Is first row 3 3 4 1. You write 3 3 4 1 semicolon. That's the second row 4 2 4 2. Then third row is 1 5 3 2. So this is the cost. Now you can apply the supply, that is a row. I code as a 100 125 as a and demand as my 120 80 75 as here. So this is my phase 1. So look at that. If I just type these things into the MATLAB file, you will get this. Okay. So now look at that. If I run the file, you will get cost as here. Now what is the next step is you have to check whether this is a balanced or not. How you check that balance or not? You have to add this. You have to add this. So these elements are denoted in the A. These elements are in the B. So you have to find the sum of A. You have to find the sum of B. So how you check that is a balance or not? If sum of A is equal to sum of B, then it's a balanced. Problem is balanced. Otherwise, the problem is unbalanced. So you can simply write again the line of this into your MATLAB file. You just simply copy paste the text from here into your MATLAB file. Now what will happen if this is not the balanced? So then you have to check whether the supply is more or demand is more. So if sum of the A is less than of the sum of B, it means the sum of this is more than the sum of this. Then you have to add, for example, if I say here is my 400 and this is 300. So it means you have to add the dummy row whose value is 400 minus 300. So how you write this in this? Cost of the end plus 1, all the values are 0. And so look at that, if I add this value here, dummy row 0 0 0 0 if this is unbalanced problem, and the A of the end plus 1 is whatever the sum of B minus sum of A. Similarly you can find if sum of B is less than of the sum of A, then you have to add the dummy column. Then you have to add here as a column here. So zeros of this, and for the dummy column this demand value change, so B is here. So when you type this all this, you will get this balanced or unbalanced problem. Now what is the next cell is you have to initialize the parameters. Look at that, you have to find the BFS. How many BFS are there in the transportation problem? M plus N minus 1. What is the M is? Number of the rows. N is my number of the columns. So it means you firstly find the number of row and number of columns in the matrix B. So I just copy this cost value as a I cost. So I just copy the element of all the cost value in I cost that will be used in the later stage. Then our task is to find the M and N. So number of the row and columns I just denoted by this size of the cost, number of the rows. This represents the number of the rows. This represents the number of the columns. I just use the capital S as the number of the allocations. For example, in the optimal solution, we see that this is allocation, this is allocation, and so on. So I initialize all those values as the 0. So whatever you will get, we will replace the elements of 0 with here. So once we will get the number of row and column, then we will define the BFS as M plus N minus 1. So in this case, what is the BFS is? M is my 3, this is 4, this is 1. So I will get as a 6 elements out of these 12 here. Now the first main task is we have to find the allocation. That is whether we want to allocate the first cell here, first element here or here. So what we do in normally is that we will calculate the penalty row, penalty column. So what is the role of the penalty is there. So you have to find the two smallest element. How you find the two smallest element in the MATLAB? So I use the command as this sort. So look at that. If I just write this command on this, look at these are the cost values. You can see it's very difficult to find the first and the second largest element. So I can simply write here as the cost comma 1 is represent for the column. Look at that. The first column 3 4 1 is arranged as a 1 3 4, that is ascending order. Then 3 2 5 is arranged as a 2 3 5, 4 4 3 as a 3 4 5, and so on. So this is the ascending order for the column wise. Similarly, you can ascending in the row wise, comma 2. So what we'll do, so if I just write here as column of this, so now we know that this is the first smallest element, this is the second smallest. So I can subtract two elements, this and this. So I can find the penalty row as whatever I get row. If you want, I can write like this way here, row sort cost comma 2. So that is a row. I look at that, the first element, smallest second element. Now I can define row second column minus row first column, that is my penalty row. So row of the second column minus row of the, why I use this, because look at that 201, look at that 201, because once you arrange in the ascending order, this second element is the second smallest element and the 1 is the smallest element. Similarly, you can define the penalty column, that is a column of this. Now once you define the penalty row and column, our task is to find the maximum of them. So I can find the maximum of penalty row. It will give you the 2 element. Penalty of the maximum here is 2. Now if it is more than 2 elements are there, for example, say this value is also 2, but this value only give you the 2 number, this and this. So we have to preserve the row also. So in order to preserve the row, I have to find all those row values which is nothing but the maximum of this. Why we take a maximum? Because from where we can start, we have to start the row or column where the penalty is maximum. In this case, there are the 2 maximum which are the same value. So we have to go in that way or in that. So we find the row maximum. Similarly, we can find the column maximum. So if I find the column maximum, this is the column maximum, this is the column maximum here. Now I can choose the index here. Now I can choose that this is the first row, so the cost of the first element. So this CR is, in this particular example, this is my CR. You can find this cost of the row wise, and cost of the column is the penalty column. So this is my here. Now once you will get these 2 elements, it means now I can enter through this or through this with the rule that cost minimum and allocation maximum. So now in this case, now how you enter them? So there are the 2 cases, whether this maximum value, that is whether this R max is same as that of the C max, like in this case maximum of the row column and the maximum of the penalty row both are same, or the second case is if they are not same. So if they are not same, then it's quite very easy, because if it is not same, then you have to enter in that particular row. So I just firstly consider a case when maximum of this penalty row is not equal to the maximum of penalty column. For example, if I say this is my 1, so it means there is the maximum of penalty row here is not equal to the maximum of this. So what do? You have to enter through this one. So if maximum of the penalty row is greater than of the maximum of this, then you have to choose the row. So this row is denoted as a CR. So then you have to find minimum of the CR, which is nothing but the cost of the R max. You save the R row index and the column index. But look at that, if you enter through this row, you have this row. If I say this value is also 2, then this is also the entering variable. Then you have to choose, if I say this is case, so if there are the 2 values which are same, then this is the finding of these elements are there. So this one is there. But how you know that which column is there? So that column is preserved by COLIND, column index. So we will find the R max, whatever the maximum position. In that maximum position, we can find the row value, finding the row index, and we will find the column index as by this, because in this case, when row is maximum, column is remain fixed. On the other hand, if my column is row, penalty of the column is maximum than the row, then we will find the same procedure. Instead of the R max, we will find the C max, and instead of the CR, we will find the column, and we will preserve row as the same, and now column, because column is this is the fixed value. So in this column, we will find the C max of this. So based on this, you will find the allocation, because after doing this, you will get either this value or this value are there. So we will find the minimum of A, this is this, and B. So minimum of the A row 1 or B column 1. Once we will get the minimum of this, then we will check that maximum. We will find the maximum allocation. Once we find the maximum allocation, this is the value, this is the index. We will find the row position, row 1, and JJ as the column index of this. So this is the allocation position, whatever the initial value allocated to them. On the other hand, else, like this way, if penalty, what is the meaning of the else is, if this condition not satisfied, like this case. So if this is the case, what will happen? You can enter through this or through this, both. Then you have to find the minimum of this as well as minimum of this, both at the same time. So now instead of using this if and else, I can copy this line. I can copy this line into the same file. Look at that. Else, finding this row of this, column preserve. Similarly, we can find the cost elements. For example, this 75 and 120, cost of the row 1, cost of this. Similarly for the column, and we will find preserve the row and finding the columns index. Now this is the C1 cost 1. Here is again C2 is 1. So now these two values, after run this file, you will get these two values are there. Now what we do, you have to check whether this, whatever the cost you have to find, minimum cost is same or not. There are the two conditions, whether they are same or not. If it is same, then what we do, you have to look at for the maximum allocation. If they are not same, then you have to choose the minimum cost and put up the allocation. So the condition is if either C1 is less than C2 or C1 greater than or equal to C2. So we case the 2-1. So if C1 is less than C2, that is a row C1, this is my C1, this is my C2. So if C1 is less than, that is a row 1, column 1, else row 2, column 2. Look at that. These are there. This is for my row wise, this is for the column wise. Then if this is there, then we find the maximum allocation. Maximum of x11, maximum of the x11. And then preserve the row. Here is the row 1. We will find the identity of matrix, allocation matrix, and then we will find for here. And this is the end for the if loop. What is the if loop is? If maximum of R max is not equal to the maximum of the C max. You just copy this, all these text into your MATLAB file. Now, what is the meaning of this? You will get the cell allocation. After completing this, you know what is the cell allocation. So after doing this, you will get that this is the cell allocation. Now you will find the value. Minimum. So minimum of the A value of the allocation index. J is for the column here. So once we get this is the 75 here. We will subtract A, this 75 to the allocation, this X value, and we will deduct 75 from the both sides. Now it's a 0 from the A. Similarly, we can deduct from B also. So we can deduct B as here. Once we will get this, then what is the next step is we will allocate this value here. So we want to move again and again. So but if you want to move again, so we have to reduce this row or the cell. I have to delete this column as the infinity, because my task is to find the minimum cost. So I have assigned here as the very large number and called as the cell cover. This percentage sign means these are the comments. This is only for your explanations there. Now this is the allocation, first allocation put up at here. Now what you do in the next step, you have to find again the penalty row, again the penalty column, and so on. So what we do is that, so we will repeat the process again and again. How many times we will perform the iterations? Number of the elements. How many elements are there? Number of the rows, number of the columns. In this case, these are 12. So you can see this is the starting phase. So instead of you have to write as a COL sort, you can write this start the loop in front of them, and at the end of this here you can write the end loop. So if you see the MATLAB file, look at that. I can find the balance allocation. Now look at that, I start with this ascending or descending order. From them you start the loop, for loop I from 1 to n, and end the loop. Look at that, I have copy each text from here one by one, and look at that, this else condition is there. You can simply copy the text, and after finding the allocations ij, we can end the loop as here, this one. So whenever you, firstly you have to type up to this text from the up to the last slide, and after that you have to go to this column position, and in the upside just type for I varies from 1 to n, and here. So this will formulate the loop again and again until this condition meets. Once you will get all the allocations, then we will print the solution. I stored all those values in the column X. Look at that, I store all this value in the column X. Then I will display in the matrix. So I look at that, I will run the file. If I look at that, if I say, look at that, this is the allocation after running that 45, 30, 25, 80, 45 and 75, and these are the same cell which we got in the optimal solution, feasible solution. Now what is that? Now we will check that whether the feasible solution is degenerate or not. How you check that? If you, whatever you finding in this X or IB, they are is equal to m plus n, then it's a feasible, it's a non-degenerate, otherwise it's a degenerate. So we will check that how many cells are there. Look at that, 1, 2, 3, 4, 5, 6. So these are the 6 allocations. So how you check that? You can simply use the command as the length of the non-zero. So whatever the elements are here, if I say, look at that, if I say length of non-zeros of the X, so look at that, this is 6. It counting that how many cells are there which are non-zero. And if this cell is equal to the BFS, but instead of the BFS, you can also write here as m plus n minus 1. If you want, you can write as a m plus n minus 1. Then if these are equal, then your problem will be non-degenerate, otherwise it's a degenerate. Now once you will get degenerate, non-degenerate, you will calculate the transportation cost. How you find the transportation cost is Cij of the Xij. This is the optimization model. So this cost is denoted as a cost, but once you run all the file, look at that, the cost values be. So this, now if I run the file, now what are the cost values be? These all are infinity because I removed them. That's why I use the command as the initialize the cost as the I cost to preserve them. So simply you can multiply the Cij, multiply Xij. Now it's a double summation, so it's a sum of them. Now finally you can print the command as the initial BFS as this. So look at that, the output will be like this way. The given solution is non-degenerate and the initial cost is 695. So that's a simple termination of this loop is there. So that's a simple MATLAB code of this VAM. Although it's quite lengthy, but it covers all those possible cases. Now you can simply replace the cost elements, replace the supply and demand, whatever kind of your transportation problem, it will solve with the help of this VAM method. So if you look at this MATLAB file, if I just run the file, and if I can, you can see, I have to solve this. You just replace the any one of the code. If I just replace this one with here, now if I run the file, look at that, what are the outputs are there. So look at that, problem is initially balanced, these allocations are there, and the optimal solution is here. Similarly, now if you want to see the complete code, otherwise you can write from the explanation part, you can just simply copy one by one from here. Look at that, I just copy one by one from this text to this. So this is a loop, this is the penalty finding, this is there, this is the condition. If penalty row is greater than or not is not equal to, then we will find row wise or column wise. After that we will find the allocations, else if they are equal we will find the rules that minimum cost, maximum allocation. So this is the simplest code is there. So I just again suggest you that you just do nothing, that you just copy paste this each lines one by one from each line as such from their explanation part into your MATLAB file, and run the any transportation problem code is there. So this is all about the VAM method. So we will see in our next class, that is the Modi method for finding the optimal solution. If you find that this video is important and useful, you can share them with your friends or you can subscribe it. Till then, best of luck students, happy learning.